Hi everyone, let's continue with the Blind 75 coding series. So today we are going to cover the third question from array section, that is contains duplicate. So let's go through the problem statement. Given an integer array nums, return true if any values appear at least twice in the array and return false if every element is distinct. Let's try to understand it clearly using some example. So here for the first input, if we see, like we have 1, 2, 3, 1, and 1 is existing twice at 0th index and at third index. So that's why for this input we are returning true. For second example, here if you see we have all elements distinct. So that's why we are returning false. And for this third example, you can see like 1 is existing multiple times, 3 times, and 3 is also existing multiple times, 2 and 3 times. Okay, that's why we are returning true. So if any element, any value appears at least twice in the array, we can simply return true, otherwise we need to return false. Hope you understand the problem statement clearly. Let's try to solve this problem. I will try to cover as many approaches as possible to solve this problem. Okay. So the first approach that comes to our mind to solve this problem is the brute force approach. So let's discuss the brute force approach. So what we can do here, we can run two for loop. We can run two for loop. And while running the for loop, we can simply check whether the element is same or not. Let's say like I have written 1, 2, 3, 1, and this is my ith for loop, and let's say like this one is my jth for loop. So definitely j is starting from I plus 1 till n. Okay, and 1 is fixed now. I is at 0th index, and j will start continuing from 1 till n. Okay, so I will check whether 2 is equals to I, basically the nums j equals to nums I. If it is not, proceed here, j will continue. We'll check whether this current nums j is equals to nums I. It is not, continue. And here I will see like nums j equals to nums I. So at that place only, like we can simply return true. Otherwise, at the end we'll return false. The pseudo code would look like this for I to n. Okay, and for j equals to I plus 1 to n. Okay, something like this we can run. And if at any places nums I equal nums j, return true. Otherwise, after the execution of this for loop, we can simply return false. Okay, let's discuss the time and space complexity of this approach. Since we are running two for loops, so the time complexity would be n square, and space complexity would be order of n, order of 1. Sorry, since we are not using any extra space to solve this problem. So this is first approach to solve this problem, that we call the brute force approach. Let's try to come up with any optimal approach. Okay. So let's see, like, can we optimize the time complexity further, because the space complexity is already optimal. Okay. So the approach to what we could do here to solve this problem, that problem we called hashing technique. So what we can do, we can store the elements, array elements, in set data structure. Okay, set data structure as a property only stores unique element. So this is the property of the set data structure. So when we insert elements, all the elements, let's say like I have element like 1, 1, 2, 3, 4, something like this. And when we start inserting these elements into our set data structure, we could simply have 1, 2, 3, and 4. because set has a property to store only unique element, and we inserted all this element into the set, we can simply check its size, and if its size is lesser than the current num size, then we know like there are some duplicate element, and we can simply return true, otherwise simply return false. So the pseudo code would look like, so iterate through array and put the element into hash set. Okay, and simply check, return from here hash set dot size less than num's length. Okay, so if it is less than, it simply means like there are duplicate elements. That would only be the case. We could have a lesser element in our hash set. Otherwise, if we have the all elements unique as unique in our original array, then the size of the hash set will all be equals to the size of the given array. Okay, let's discuss the time and space complexity for this approach. So if you see here, we are just iterating the array, and to iterate the array of length n, the time complexity would be order of n. Okay, and after that, we are just inserting the element into the hash set. So here, the add operation in hash set, add operation in hash set takes amortized order of one time complexity, order of one time complexity. That's why the overall time complexity would become order of n. So let's say like instead of hash set, we have used either tree set. Okay, instead of this, if we have used tree set, then the time complexity would become order of n into log n. Okay, because to insert the element in tree set, the time complexity is log n instead of order of n. So that's why we prefer to use hash set instead of tree set or linked hash set, because if we use linked hash set, although the time complexity of add operation in linked hash set is order of 1, but linked hash set used to maintain the insertion order. That is not the requirement here. So definitely, like internally, it has to maintain few pointers, and unnecessarily operation would be required, and that is not our current use cases. So if we have a use cases where we need to maintain the insertion order also, then we could prefer a linked hash set over hash set. The time complexity for both hash set and linked hash set add operation is amortized order of one. Okay. So yeah, the final time complexity would be order of n, because we have chosen hash set implementation, and the space complexity would be order of n, because in worst case what would happen, let's say like I have all elements as distinct, and definitely like when we are inserting these elements into our hash set, we would insert all the elements. Okay, so in worst case it would take order of n, so the space complexity is order of n. Now we discuss two approach, and we can see if we compare this approach with the previous approach or brute force approach, we see the time complexity we have reduced from n square to order of n, and we have increased the space complexity from order of 1 to order of n. Now let's try to come up with some another approach. So hope you here you understand this hash set, tree set, and linked hash set. Let me reiterate over that one because it's an important concept. So set interface is present in Java collection. Okay, and this has three major implementation. We got hash set, linked hash set, and tree set. And add operation, for add operation, the time complexity in hash set is order of 1, linked hash set order of n, and linked tree set it's log n. So it's internal ds that they here uses hashing technique. So both hash set and linked hash set So that's why the time complexity for them is order of one. But Treeset internally uses balanced binary search tree, balanced BST, like red black tree. So that's why the time complexity here for any balanced binary search tree for performing the add operation, remove operation, delete operation is log n. Okay. So that's why we prefer here a linked hash rate, hash rate. So the question would come like, what is the difference between hash rate and linked hash rate? So we can write that one. So hash rate doesn't maintain insertion order, doesn't maintain insertion order, insertion order. Whereas linked hash rate maintain insertion order. Whereas preset maintains sorted order. So by default is ascending nation. Okay. So that is the difference between these two, hash rate, linked hash rate, and tree set. And we prefer here hash rate because we just have to store the elements into the set and take a call. Okay, and all three follow the same set interface property that is stores only unique element. Now let's try to come up with any approach that we can utilize to solve this problem. So let's discuss third approach. So I'm just trying to cover as many approaches to understand all the required concepts and that we can utilize to solve any other question or similar questions. So in third one, what we can do here, like we can perform sorting technique. So if you sort the array, okay, then the same element would come together. For example, if I have a use cases, something like this. After performing sort, we would have one, one, two, two, three. So after that, we can do a linear traversal. The second step, what we can do, traverse the array and check for duplicate. And for checking the duplicate, we just see the next immediate element. If they are same, then we can see like, yeah, it's a duplicate one, and we can simply return true there. We can say traverse the sorted array to check for duplicate. For example, here if I have this array configuration, I will simply start from here and I will check the next element I plus 1. If they are same, then I can simply return nums I equal nums I plus 1 return true. Otherwise, continue and at the end, if you're done with the processing of the array, return false. Return false. So let's discuss the time and space complexity for this approach. So here if you see like we have two major steps. One is performing the sorting and the time complexity for the sort operation is order of n log n and time complexity to iterate the array is order of n. So overall time complexity would be n log n plus n, that is equals to n log n. Okay. What about space complexity? Space complexity is order of 1 since we are not using any extra space. So yeah, like we have discussed three approaches to solve this problem. Starting from the brute force approach, we discussed brute force approach, and after that we understand the hashing technique, and after that we understand the sorting technique. So yeah, let's try to do the quick coding for this one. So I will implement all the three approaches. Let's first implement brute force. So this is the brute force approach. Let's validate its correctness. Let's try to run it for all the inputs that are given to us. Let's check whether it is working as expected or not. Okay, here you can see like for all the provided input, it is working as expected. Let's try to implement the second approach. Hashing solution we can name it. Okay. So in the hashing solution, we understand like require some extra data structure to store the elements, and here like we decided to go ahead and use the set data structure. I'm going to use the set data structure. We'll just iterate the array and try to insert all the elements into this hash sheet. And after that, we can simply and then take a call whether the hash sheet dot size is less than nums dot length. If this is the case, then we understand like there are duplicate elements. Let's update the calling method from brute force to hashing solution so that we can understand the hashing solution is also working as expected or not. So here also if you see like we are calling the hashing solution, and for all the given input it is working as expected. Let's try to implement the sorting based solution also. Sorting solution. Okay. Let's try to check it. Implement it quickly, and after that we can check its correctness. Let's sort the array. Now what we can do, either we could use for loop or while loop. Here I would prefer to go ahead and choose the while loop to implement this solution. If you want, you can choose the for loop also. It's up to you. While I less than n minus 1 and I plus 1 is also less than n minus 1. Thus it could be a case like while checking for the next element, if nums I equal nums I plus 1, simply return true. Simply means like we find the duplicate, we are returning true. Okay, otherwise I will just continue with my for while loop, sorry. So I'm just incrementing my I, and at the end if we are done with the processing, then we can simply return false. Okay, let's try to call this method to validate its correctness. Okay, here it is failing. So let's see like for which test case it is failing. So I see like for the second last test case 1 and 1 it is failing. Let's try to see why it is failing. 1 and 1. For this test case it is failing. Since it is already sorted, so we could have 1 1. So we are restarting our for loop, sorry, while loop. So here n would be 2, while I less than n minus 1, we are doing the standard check. Okay. So while I is less than n minus 1, that is within the range, and I plus 1, because at any point of time we need to check for this current index. Let's try to write down the state. I is equals to 0 here and n is equals to 2 here. So the first check we are doing 0 less than 1 and I plus 1, 1 less than, here what we are doing, we are checking n minus 1. Okay, so that is the culprit here. So here we need to make sure like we have proper boundary condition. So for any particular index, max what we can do I plus 1, and this I plus 1 should be valid. Okay, otherwise we could face out of bound exception. Okay, so here if I, let's try to run it. So although if you see here like I plus 1 is also having the same check that we are having here, if I just move this I plus 1 to the right hand side, then we could have the same thing. Okay, so here let's take for one more example. What could be the situation here? But for this element, definitely the call should not go in this while loop. We should directly return it. Okay, so it's an unnecessary check here. That is sufficient, we can say safely. And let's try to run our code on the original input that we have chosen, and let's check its correctness. It is passing for all the inputs, and we have already discussed the time and space complexity, and we know like this hashing based solution is the optimal one. So what we could do, we could submit, or let's submit this sorting one first. So it got accepted with 21 millisecond, like it has taken. Let's update it to hashing based solution and try to compare. So although it is very system specific thing, the next call may land to some another server. It is working. Let's submit the solution and check its correctness. So here if you see like it has taken 20 millisecond. So earlier one has taken 21 millisecond. This one has taken 28 millisecond. So yeah, that's all I have from my side for today problem. That is contains duplicate. We discussed three approaches: brute force approach, hashing solution, and sorting based solution.